All right, folks, welcome once again. So this is week three, right? So final week of our course, and this is session number 11. So today is Monday, as you well know, and we'll finish the course on Friday, on this Friday. All right. So we are currently in module 7, which we started on Friday. So we need to finish this today, okay, in the first hour. And then in the second hour, we'll be doing module 8. In both these modules, we are essentially looking at an eclectic bunch, right? There's no theme to these modules. We are basically trying to cover a wide set of services, which are especially important in production or live environments. Okay, so in module 7 we are looking at 5 services. In module 8 we are looking at 5 services. These are across networking, management tools, messaging services, deployment tools, across categories, right? Okay, now in this module, in module 7, these were the objectives that we started with. So we are looking at 5 services, Route 53, which is a DNS service, and then 4 management tools, right? And what we've done so far is we've looked at Route 53 and 3 of these 4 management tools, right? So we only have to cover cloud formation today in the first hour, and then we'll start module 8 in the next hour, and that's a similar kind of module, right? Because we'll be talking about 5 more services in that module. Okay, so yeah, so we'll use the same sheet here for the moment, because we're still in module 7, right? So first I will use the same sheet, and then I'll create another one for the next one. Okay, so let's do that. Use the same sheet, mod 7, other services. If you don't have a link to this document, please let me know. Okay, now this being Monday, we'll also do some extra time. So after we finish our session today, we'll do a review of the previous week, right? So I think one of you has already raised a bunch of questions, right? So these questions I saw before we started the class. So Shyam, you have a bunch of questions here, which it looks like you've done a bit of practice, right? So that's good, and others as well, right? If you have any questions based on some work that you might have done over the weekend, right? Please feel free to write your questions in this sheet. Let me in fact rename this. Let me rename this sheet and call it week 2 review. Right? So we'll do a review. But this we'll do after we finish our allotted time, right? So after 2 hours, we'll do this review. Maybe we'll spend half an hour on these types of questions. Okay, all right. So also, I saw a bunch of you have filled up this feedback form. That's very nice. Really appreciate it. The feedback is very useful. Okay, and hopefully I'll incorporate some of the feedback in the remaining sessions that we have together. Okay, so with that, let's start, right? Let's start looking at the last topic today in this module, and that topic is cloud formation. Okay, so as far as management tools are concerned, these were the 4 topics that we were looking at, right? So let me just do a quick review of the 3 that we've already spoken about, and then we'll start with cloud formation. Okay, so we looked at Cloud Trail. Cloud Trail is sort of an audit trail, right? So if you have users in your AWS account, this will be using the identity and access management service, right? So you can create users for people in your team, or even for applications and scripts, right? And these users can have permissions. They can also belong to groups as well. So once you create those users, and then the users will start using the AWS API via the web console, or the command line interface, or the software development kit, right? So whatever actions they perform, these are basically API calls, right? So they're calling the AWS API from any of these 3 interfaces, and those API calls are recorded, right? So they're logged. And you have information such as date, timestamp, the source IP address, the action performed, the resource on which the action was performed, and so on, right? So this information is very useful, and I gave you the example of a bank where this kind of information is, mandatory, right? So you need to have audit logs for all kinds of resources. This could be network access, or operating system access, application access, right? So everything is logged in a bank, and the logs are very useful both for proactive monitoring as well as for post facto analysis. In case there's a security incident, for example, the first thing that you would look at is the audit trail, right? So that's what CloudTrail provides you. You can understand it's a very important service. All right, we also spoke about CloudWatch. This is more commonly used. CloudTrail is very important from a security point of view, but CloudWatch is more commonly used because it is used probably by all types of organizations, even very small organizations, because it collects data, right? So it collects metrics about the different types of resources that you may have. So EC2 instances, RDS, S3, EBS, Elastic MapReduce, right? So whatever resource you have, any resource that you might have in your AWS account, right, that will be monitored by CloudWatch. This is done automatically. Okay, in most, well, for all services, it is done automatically. It is free of cost in the sense the cost of the resource covers the cost of CloudWatch as well. Right, so the data is available, and it's usually collected at a 5-minute frequency. So every 5 minutes, 5-minute interval rather, and you can turn on detailed monitoring where the data is collected on a 1-minute interval, and so it's a time series type of data, right? So you can then chart it. You can do some analysis. You can look at the trend. And lots of decisions can be taken based on CloudWatch data, right? So capacity planning, problem diagnosis, cost optimization, those kinds of decisions can be, performance tuning as well, those kinds of decisions can be taken using CloudWatch data. All right, so that was CloudWatch. We also spoke about Trusted Advisor, right? So this is a service which basically advises you on your compliance with best practices, right? So there are, you can do things in a bad way, okay? And remember that even from a security point of view, it's a shared model, right? So AWS is responsible for certain things, but you are responsible for certain aspects of security. For example, your security groups may be too open, right? They may not be the rules may not be well defined. You may not be using VPCs properly, right? You may have sensitive servers in the public subnet, for example. So these kinds of things can happen. You can make mistakes, right? And the Trusted Advisor will basically highlight issues that you may have with your infrastructure, right? So these are the issues are highlighted under 4 categories: fault tolerance, security, cost optimization, and so on. And the issues are prioritized, right? So you have red, orange, and green, and you also get recommendations on how you can fix those issues. Okay, so Trusted Advisor is only available with a paid plan, and it's very useful, I think, for ongoing monitoring of your compliance with best practices, right? And because things can change every day. People may change things, change the configuration, launch new resources, right? So every day there's a risk that you may be doing something wrong, and monitoring a Trusted Advisor on a regular basis can sort of help you remove any potential issue. Okay, so this was another service, and now we need to look at the last service under this management tools, and this is CloudFormation. Okay, so let's talk about it. So let me find one slide. I just have one slide on CloudFormation, and then I'm going to show you a demonstration. Okay, so CloudFormation, actually the mantra of CloudFormation is infrastructure as code. Okay, infrastructure as code. You might have heard of configuration as code, and that is used in the context of tools like Chef and Puppet. right? Or Ansible. You might have heard of these tools. So what these tools do is they help you automate configuration activities. Things like say software installation, Apache installation, for example, or MySQL installation, configuration, server restarts, application server restarts when the configuration is changed, right? So these are steps that you normally have to take when you're setting up your server. And then if you're managing environments at scale, if you have lots of changes going on frequently, then these things have to be done again and again and again. Right, so configuration management tools help you automate all these things. You can write chef recipes, for example, and then you just have to invoke the recipe, and you don't have to repeat the steps manually. Right, so that's configuration as code. Now you have in the cloud, you have infrastructure as code. This is a completely new thing, right? Because what it means is you can instead of creating your infrastructural resources manually, right? Say an auto-scaling group, or a load balancer, or an RDS instance, or an S3 bucket, right? Instead of doing this manually and then configuring it and then making sure everything works fine, you can define your infrastructure as code, as code, and then you simply have to execute that code, and your infrastructure creation will happen in a fully automated fashion. Okay, so that's a big deal. That's a big deal, because so far, before cloud, we just had, we could automate things using scripts, for example, right? So you could automate, say, application deployment to some extent. There were, CI, continuous integration, continuous deployment tools like Jenkins, right? You had configuration management tools like Chef and Puppet. So there was automation before the cloud, but now in the cloud, what's happening is even the infrastructural provisioning is being automated, right? So you don't have to create resources manually. The whole thing happens automatically, right? All you have to do is write down what you want in your infrastructure in a template, right? In a CloudFormation template. Okay, so this is the template is basically a JSON file, right? It's a JSON file where you define what resources make up your stack, right? So it could be, say, EC2 instance, auto-scaling, RDS, right? A VPC. So any kind of resource. CloudFormation is a very general service. It's not it's not meant only for web applications, let's say, right? So you can create any sort of application using any type of resource just by defining all the resources, the properties of the resources in the template, right? And then you simply give the template to CloudFormation, and CloudFormation will create the stack in a fully automated fashion for you, right? So what's the big deal, right? What's the benefit? What are the use cases? So what happens is, for example, you may have a very complex stack, right? So there could be, say, 3 tiers, right? So you have load balancer, web servers, auto-scaling group, another load balancer, application server, auto-scaling group, RDS instances. You may have S3 buckets, CloudFormation. CloudFront, right? CloudFront, the caching network. You may have EMR clusters. You may have Elasticache databases. You may have DynamoDB as well, right? So it can become a complex stack. And then if you want more environments, for example, right? Let's say you want a test environment fast, right? Because business wants everything fast. So to create a test environment from scratch is a big deal, because you have so many different types of resources, right? You're prone to make mistakes, okay? Because you don't do these things. You do them frequently, but not on a daily basis. So you may make mistakes when you're creating environments, right? It also takes time to do all these things. People may change. Right? New people may come in who don't have the same level of expertise. So creating environments is, again and again, especially in a dynamic organization where you do a lot of testing, right? You need new environments all the time. There, it makes sense to automate the stack creation, right? So instead of doing it manually, you simply, with a few clicks, you have a template for the stack, and with a few clicks, you can create a test environment, right, in a fully automated fashion. Other use cases are there as well. For example, you may want to create a DR environment, right? So you have a stack in one region, and then you want to be prepared for disaster recovery, right? So you want to bring up your stack in another region, right? And again, the same process. When there's a disaster, if you want to create a stack in the other region, it'll take time. You may make mistakes, right? So those kinds of things can be avoided if you had a CloudFormation template, right? So with a template, what happens is, once you test it, you can be sure that the environment that will come up in the same region or any other region will be exactly the same, right? Exactly the same. So you have consistency in the stack creation, right? You can be sure that the environment will come up in exactly the same way that it does in the main region or the main live site that you have. Okay, so these are some of the benefits of CloudFormation. Okay, so here, what we need to understand, before we look at CloudFormation is the template, right? So a template is actually a structured JSON document. So and it has a syntax. Okay, it has a bit of a syntax, and you need to get familiar with the syntax to some extent. There is a learning curve here. Okay, there's a learning curve here. It's not very simple. Okay, so let's first talk about the template, right? I'm going to show you what it looks like, what are the different parts of the template, and then I'm going to show you a demonstration of how we can use a template to sort of create a stack using CloudFormation. Okay. All right. So let's talk about the template. Okay, so what I'm going to do here is I'm going to cover a few of the basic parts of the elements in a template. All right, so let's look at this one by one. So the first one is a template will have a section called resources. All right, and the resources will contain will define the various resources that you have that make up your stack, right? So any kind of resource, EC2 instances, RDS instances, EMR clusters, Elasticache, right? All those types of resources have to be defined in this section, in this resources section. Okay, so in this slide, you can see there's an example of a resource. This is actually an S3 bucket, right? And the name of the bucket is this one, hello bucket, right? And the bucket has properties, okay? And the properties are, these properties will be familiar to you, some of these at least. So this is a website. So the bucket is being used as a place for your static website, and the website configuration includes the index document, right? So this is something we have done before in our demonstration, where we configured a bucket to be a static website, right? And as part of that configuration, we had specified what document, what HTML file is our index or the home page, right? So the same things that you would do, from the web console, right? The same things can be done via the template, right? That's the main message here, that instead of doing things manually from the web console or from the command line interface, you can simply write down, right? This is code essentially, right? Remember, infrastructure as code. So we're simply writing down what we want, right? We want a bucket. What are the properties of the bucket? We sort of define that in this template. Okay, so same things that you would do manually, you're simply writing this as code. Okay, now also there's one more very important part of the template, and these are parameters, right? So the first one is resources, where you define what kinds of resources you want. The second important part of the template is parameters. Okay, so parameters are, as the name tells you, it's basically a way for you to pass values, parameters at runtime, which means when you're creating your stack using the template, right? So when you're creating the stack, you can supply, say the server size, right? So you have EC2 instances, and you can supply at runtime, whether you want a micro instance or a small instance, right? So the benefit of parameters is that you can use the same template for different types of stacks, different types of environments, right? So in a production environment, you might want a larger server, right? A larger server in your auto-scaling group, whereas in a development environment or in a test environment, you might want something smaller, right? So the parameters are very important because it allows you to use the same template, right, over and over again, and you can have different kinds of stacks using parameters. Okay, all right. So that's another important part. Mappings is another section. Okay, and this is probably the most confusing part of the template. But here, what happens is you have something like this. The table on the left side, right? What it says here is if the region in which the stack is being created is US East 1, then use this army, right? If it is US West 1, then use this army, right? So the armies are different based on the region in which the stack is being created, right? So what this means is, it's the same software, right? Let's say you're setting up Ubuntu servers, then the Ubuntu software is the same in all the regions, but remember the army is a regional resource, right? So one army ID or one army in one region cannot be used in any other region, right? So you need to have the same software as a different army with a different ID in the other region, right? So when you create this mapping, what you're really saying is you can run this template. This CloudFormation template can be run in any region, right? And CloudFormation will very smartly, based on the region in which the stack is being created, it will pick the right army, right? So in that sense, mappings are similar to parameters in that they make the template more usable, more reusable, right? They make it more generalized so that you can run a template in any region. Right? You can run a template in any region. There are other types of mappings that can be created as well. For example, the server architecture, right? Based on the architecture, select a certain army. Okay, so mappings are not just for regions. They can be used for multiple types of properties. Okay, so these three things are very important: resources, parameters, and mappings. All right. Okay, now you also have certain other things. For example, the ref function. Okay, the ref function. This is basically reference. It's a short form of reference. And what is happening here is, you have a EC2 instance, which is a resource, and then the property of the EC2 instance, security group is a property of the EC2 instance, as you know, right? And the security group is defined elsewhere in the template, right? It's defined elsewhere in the template, and the ref function is used to sort of refer, to link up the security group property with the actual definition. So what the ref function is doing here is that it's linking up, it's connecting different parts of the same template. Okay, so this is an important function. There's another function called get attribute, get at for short. And what this does is at runtime, when you're using this template to create a stack, at that time, the get at function can go and talk to the AWS backend and fetch some values, right? So in this case, the get at function here is basically trying to get the domain name of a bucket. Okay, it's trying to get the domain name of a bucket. If you know the name of the bucket, right, we just apply that, and the get at function will get the domain name because the domain name is required in this properties of this CloudFront distribution, the resource, right? So we need the domain name, and we don't have it with us, but we do know the S3 bucket name. So based on the name of the bucket, we pull in some information about that bucket. Okay, so you can see it's not a static template, right? So you have certain functions, certain capabilities where things can be pulled dynamically while the stack is being created. All right, so this is another function, and then you also have this function called join, and this join is like a concatenation. It can combine static values as well as dynamic values and create a string, right? So this is often used to create endpoints, targets, right? So in this case, you can see here there's a join function here, and this is being used to create a target for the health check of the load balancer, right? So you know that the load balancers do a health check, right? But they need a target, and the target URL is being created here using the join function. Okay, so I think these are the major parts of the template, right? Let me just recap once again. So first of all, we have resources, right? So this is where we define what resources make up your stack, right? So if you have a web application, you may have a load balancer, an auto-scaling group, you may have RDS instance, you may have multi-AZ deployment, right? All this may be in a VPC, right? So all these things have to be defined in the resources section of the template. Okay. All right, then you have parameters. These are used to supply values at runtime, and this gives you makes your template more flexible, more generalized, right, more reusable. You can use the same template to create different kinds of environments, a production environment, a test environment, a development environment, a performance testing environment, a DR environment, right? So all those things can be done with different values, right? Different values for things like server size, the key pair to be used, and so on. All right, then you have mappings, which also are used to sort of generalize the template, right? So if you have mappings, then the same template can be used. In this case, in this slide, in this example, the same template can be used in different regions, right? Even though in different regions we need to have different armies, because that's how it works. An army in one region cannot be used in another region, right? So you need to define different armies for different regions, and all that information can be sort of codified in this template. Okay, so these are the three major things, and then you have the functions, which are this one. The ref function links up different parts of the template. The getadd function can fetch some information at runtime, and then you have the join function, which can basically create endpoints, some sort of concatenation of static and dynamic values. All right, so this is CloudFormation. Okay, now I'm going to show you an example of this process, right? So what we want to see now is, if we have a CloudFormation template, how do we use that to create a stack, right? So I'm going to use a tutorial that is available. You can practice that later, right, in more detail. But I'm going to do the first step maybe of this tutorial. So this is called updating a stack. Okay, so CloudFormation can be used not just to create an initial stack, it can also be used to update a stack, because updates to a stack are normal, right? We all change our stack once we create it. So that's possible as well, and that's why I've chosen this tutorial. Right? You should practice using this tutorial, because it's important to understand that CloudFormation is not just for initial stack creation; it's for ongoing updates as well. All right. But for the moment, in this demonstration, I'm going to show you the first step here, which is creating the initial stack. All right. Next, you can practice on your own. How do we update the application, right? If you have a new version of your application, how do you use CloudFormation to apply that update to your stack? Third, you may want to change your instance type, right? You may have a small server that's no longer sufficient. You want something bigger. How do you change that? Again, using CloudFormation, and so on, right? Finally, the last step is very interesting as well in this tutorial. What happens here is you convert a simple single server stack into an auto-scaled stack, right? Because that may happen. Initially, your product may be small, right? You may have a few users. Later, as the product becomes more popular, you might want to change that single server to a full-fledged auto-scaled load balance type of stack, right? So you can make those kinds of changes as well using CloudFormation. All right, so this is a very good tutorial. Let me paste this here in the sheet, so you have a reference to this, and you can also practice this later. Okay, but for now, I'm going to show you the first step here, which is how do we create a stack using a CloudFormation template. Okay, all right. So first of all, let's take a look at this template. Right, so this is the template. Actually, it might look a little bit complicated, right? It looks complicated, but it has the same, sections that I explained in the slide, right? So you can see here the parameters section, right? You can see here the mappings section, right? And you can also see the resources section. What's happening here is it's a single web server, right? It's a single web server, and it has a simple PHP application installed on this web server. Okay, so by the way, in this template, what's also happening is the PHP application is being deployed automatically, right? So CloudFormation is not just creating the EC2 instance; it's also doing some other stuff. So, for example, it's installing Apache and PHP as well, right? So it can also do some bootstrapping type of things once the server is provisioned. Okay. So it installs Apache and PHP, and then it deploys this index.php, a simple PHP application. It deploys automatically, right? So it's part of the CloudFormation scripts to do this kind of work as well. Okay, so this is the template, and what we want to now see is if we have this template, how do we use this with CloudFormation to create our stack? right? So what I'm going to do is I have this template here already. Okay, so I have it on my computer. Okay, so this is a text file which I've simply copied from this tutorial, and I've saved this text file on my computer. Okay, so this template is already with us, and now what I want to do is I want to create my stack using CloudFormation. Okay, so let's find CloudFormation under Management Tools, and now we can simply, let's go right ahead. Let's create a stack. Right, so I'm going to create a stack, and the first step we do is supply the template. Right, so you can use a sample template over here, but in our case, what we'll do is we'll upload this template, right, which has our stack. So I'm going to choose this option, upload a template, and from the picker, I can basically select the template, right? So this is the same template that's available from the tutorial. All right, so this is version 1, let's say, right? This is version 1. The reason we have multiple versions is because, remember, CloudFormation is about infrastructure as code, right? So when you change your stack, when you change your template, you can have multiple versions of the template, and you can pick whichever version you want for your stack. Okay, so right now this is, let's say this is version 1. Okay, now that we have uploaded the template, it should be very simple. Okay, it should be very simple because remember, all the information that is required to create the stack is already available in the template, right? So we don't need to do too much after this. Okay, it's just a matter of uploading the template, and then it should be very simple. But there may be a few more steps here. So maybe just the stack name, right? So my CF stack, let's say. Okay, all right, and then this is the parameter, by the way. The parameter is actually defined in the template itself, right? So this field is actually coming from the template itself. All right, so let's just stick to the default value, right? This is a default value. If you want something different, you can change that, but let's stick to the default value here. All right, the other stuff you can just leave alone for the moment, right? Default values are fine. Remember once again that all the definitions, all the properties are already defined in the template, right? So we don't have to do much except maybe supply the value for the parameters, right? So now let me create this stack, right? And CloudFormation will now follow the instructions given in the template and create your stack, right? So this is a simple stack. There's only one EC2 instance. It has a security group, and also once the server is provisioned, there's a bit of software installation, a bit of configuration management, right? So you have Apache, PHP being installed, and a PHP application being deployed, right? So it's a combination of infrastructure provisioning and some configuration management as well. Okay, so all that is happening now, and this will take a bit of time for the whole thing to get done, right? But you can follow the activities, right? So there's like a running commentary here. CloudFormation tells you step by step, right, what it is doing. So you can see here, first it will create a security group because without the security group, the instance cannot be created, right? So you can see there's a bit of intelligence here, right? It will create the stuff in the right order. Okay, so first the security group, then now it is trying to create the EC2 instance, right? Once the instance is created, it'll install the software, Apache and PHP. It'll deploy the PHP application, right? So once all that is done, it will say all done, right? The stack creation is complete, okay? And then all we have to do is we can go to outputs, right? And here we'll find a URL. Right? We'll find a URL created using the join function, and we just have to click on that URL, and we'll have our sample PHP application up and running. Okay, so that's what is happening right now. We'll just have to wait for the process to complete. Okay, and remember, this is a simple stack, right? But you can use CloudFormation for any kind of stack, no matter how complex, no matter what type of resource is used in your stack. Okay, all right. So let me stop here. We'll come back to this once the creation is complete, right? But let me see if you have any questions so far. All right. Okay. So this question here, Babita, how is CloudFormation different from creating the army? Creating the army. Okay. So that's question number one, right? So there's two questions here. So first question is, how is CloudFormation different from creating the army? Okay. And it's a good question. It's a good question because army also is, to some extent the same thing, right? If you have an army, you can create your servers, right? So it's also some kind of template. Okay. So army is also a kind of a template. You're right, right? And you can create the server uh, many times, right? Many times using the same army, right? But what is CloudFormation then? So CloudFormation is like an army, okay, but for an entire stack. Okay, remember, army is only for a server, right? So if you have a web server, you need one army for the web server. If you have an app server, you need another army for the app server, right? So an army is only for one kind of server, right? Whereas CloudFormation can create the whole stack, right? You can have many things in a stack, and like I mentioned, right, load balancer, auto scaling group. You can't create an auto scaling group using an army, right? You have to create a launch configuration and then specify the auto scaling group's size, desired capacity, scaling policies, and so on. Right. So an army is a small part of auto scaling, right? But in CloudFormation, you can include the definition of of an auto scaling group, of load balancers, and so on. Okay. So let me just to explain this further, right? If you have a web app, right? Let's say an n-tier web app, right? So this has a web tier, this has an app tier, and it has a DB tier as well, right? So you need army for each of these, right? Army, sort of web server army, right? You need an army for this. You need an app server army, right, to create your app servers, and then you'll need a DB server army if you're doing this on a EC2 instance, right? So you need different armies for each tier, and then also you'll have to do a lot of things manually, right? You'll have to create an auto scaling group for the web tier, another auto scaling group for the app tier, right? So a lot of manual work, even though you have an army. Okay. All right. Now in CloudFormation, what happens is you don't need you still have armies, right? You still have those armies. Okay. So in CloudFormation, what happens is you define a single template which includes definitions of all tiers, right, and also includes the army, armies, right, the three armies. It includes the three armies above as part of the definition, right? So you can see the difference now, right? With armies, you still have to create each tier individually. You have to create the load balancer manually, the auto scaling group manually, right? Everything has to be done manually, even though you have an army. Whereas in CloudFormation, you just create a template, and the whole thing, the n tiers, right, are created for you automatically. All right. So that's the first part. The second part was, can we generate the JSON template the first time by going through the console and then remodify, reuse it as per your need? Yeah, so it's also a good question, right? So the problem is, the problem that you're trying to solve is that CloudFormation template looks complicated, right? So how do we create this in a simple manner, right? That's what your question is really, right? And it's a good question because it does. You can see the CloudFormation template is quite complicated, right? It is complicated. So the first time getting the first draft of the template is a barrier, right? After that, the modifications are simpler, right? As you say, the modifications are probably simpler but creating it the first time is hard, especially if the stack is very complicated, right? So there are multiple options. Okay, one option is you can create a CF template using an existing running, right? You may have say a live environment, right? So you can use that live environment and create a template based on that. Okay, so you can create a CF template using an existing stack. Okay, this you have to run something called Cloud Farmer. This is a tool. Okay, it's in beta. Let me also say that here. So Cloud Farmer is a beta tool that you have to run. It's an application, right? And then once you run it, it can scan your resources, right? And you can pick what you want included in your stack, right? So you can select. You have 10 resources. You can say, okay, I want number 1, number 2, number 3, number 7, number 8, right? You can pick the resources you want included in your stack, and then CloudFormer will generate the stack for you. Okay, so this is one option. The other option is there's also a visual designer that is available. Okay, visual designer is available. Can help, right? This can help to simplify the template creation, as well as the maintenance. Okay, so this is another option that you have, and the third option is there's lots of sample templates and snippets available, right? So you can just combine, you can pick whatever template you want, whatever snippet you want, and then you can sort of include that and then finalize it, right? So there are multiple ways of making the process simpler, right? For example, let me show you a page here, right? CloudFormation templates. So you can see here, there's a link here, CloudFormation templates, and you have templates and snippets, right? You have some frameworks as well, say Ruby on Rails or PHP, right? So if you look at the sample templates, you can see there's a bunch of templates for different types of resources, right? And resource groupings as well, right? So you can see auto scaling. There's a template. There's an auto scaling group with scheduled policies, right? So those kinds of things are there as well. So you can pick these and include them. So this will make things faster, right? Okay. Also, if you click this, you can see the designer as well, right? So there's a designer, a visual tool. This can help you create and maintain templates in a simpler fashion. Okay. So this is a designer, and what it also does is you can sort of pick. Drag and drop, basically, right? You can do stuff like this, and also if you click on any particular resource, the template, right, the definition only of that resource is sort of highlighted, right? So this becomes easier to edit by using this visual. Okay, all right. So let me give you this link as well. This is the CloudFormation templates page here. Okay. All right, Gajendra, your issues are resolved. That's great, right? That's great. I hope Velan was able to help you as well, right? So that's great. Okay, so Windows as well, right? So Windows via PuTTY as well. Yeah, that's what I wanted to check. So that's good. That's good. Great. So this is great news. All right. Next one, Rao. Where can I see logs so that I can see my errors and correct the script and rerun the script? Yeah, that's a good question, right? So what happens is, if what Rao is saying is, look, sometimes the template may not be right, right? So it may have say some kind of syntax problem, right? You may have forgotten one bracket. Right, or there could be other types of problems as well. Inconsistencies in the rules, right? So it's not guaranteed that CloudFormation will always be successful in creating a stack based on your template, right? So there has to be some kind of error handling, and then if there's a problem, some kind of log, right? Some kind of information about what the problem was, so that you can correct the template, right? So that's a very good question as well. So what happens here actually is you can see here if this has gone through properly, right? This has successfully completed, right? So there's no problem. But if there's a problem here, then you would find it here, right? It would say something like error, right? And then you would sort of click that line, and you would see the information. Okay, so all the information will be available right here right from the events tab. Okay, and if your template has a syntax problem, right, missing a curly bracket or some kind of word, command or property that is not understood, then it's likely to give you an error right away. Okay, even before the creation starts. All right, so everything will be here in the CloudFormation dashboard. Okay, so let me just write that here. So the errors and the diagnostic information will all be available right in the CloudFormation console. Okay, so all that is given here. If it doesn't finish the creation, it rolls back as well. Okay, it rolls back as well, and will give you the information about where it failed. Okay, so CloudFormation can roll back. Okay, can roll back the changes if there is an error. Right, and there are options there as well. You can do a complete rollback, or you can choose not to just to stop where the error occurred. Right, so there are multiple options there. And remember, the errors can be say with syntax, or it could be runtime errors. A common error, for example, is if you try to use EC2 instance types, right, without VPC. So like this CloudFormation template has no VPC, right? And certain instance types can only run within VPCs, right? So that's a common problem. So if you try to use VPC, only EC2 instance types without a VPC, right? So this is the kind of thing that can happen. So then it doesn't know till it runs, right? It tries to create your stack, and then it discovers that this instance is not coming up not coming up because it can only come up within a VPC, and the template doesn't define a VPC, right? So these kinds of things, which are runtime errors, right? You can't know that in advance. Those also you will see it in the console directly. All right. Okay. So yeah. So this question here, Subani, is there any GUI tool to generate the template code automatically? Yeah. So I just explained that, right? So there's a tool here. This one here, right? So this is a tool called CloudFormer. Okay. So there's something called CloudFormer. Okay. This is in the beta stage, right? So it may have some problems, but you can run this CloudFormer. It's an application. Okay, it's an application, and that lets you select. Okay, it lets you select resources from your existing stacks for inclusion in your CloudFormation template. Right, so basically you can create a template from an existing environment. Okay, that's what this is. All right. Okay, and there are many CloudFormation templates that are freely available as well. Okay, so if you just do a Google, say for a WordPress site, right, CloudFormation template for a WordPress site, you'll probably find it on the internet, or even in the when you're creating EC2 instances, right, you'll find templates there as well. Okay, all right. VisualOps.in, is it good or not? I'm not sure. I don't know about it. Okay, I don't know about it, but maybe I'll take a look at it. Let me just see what this is. Okay, it's not available at this point. So anyway, I'm not familiar with it. All right. Okay. So that concludes, right? That concludes our module 7. If you have any other questions, let me know. We have some time. Okay. So let me know if you have any other questions on this module. We've looked at Route 53 networking service, right? DNS service, and we've looked at 4 management tools, concluding today with CloudFormation. Okay. Let me know if you have any other questions. Okay, so now let me create another page so that we can start mod 8. Okay, so this will be for module 8, and module 8 is similar to module 7, right? It's similar to module 7 in that we are here as well. We are looking at 5 more services. Okay, 5 services in mod 7, 5 services here, and this to give you some width, right? So you should be aware of more and more AWS services, because as a solutions architect, you need to pick the right service for the right problem. Okay, so 5 more services here. All right, so let's look at the objectives of this module. Okay, so here we'll look at 5 services, and 3 of these services are SES, SNS, and SQS, right? So now these services are called messaging services. Okay, they're called messaging services. Earlier they used to be called application services, and after that we'll look at Lambda, which is a very interesting development, right? It's a new service. And this is Lambda is basically a serverless computing service. Okay, so you can run programs, but you don't have to create servers. Okay, so that's what Lambda is. Very interesting. Has interesting use cases as well, and we have to wait and see how this develops, right? But it could be a game changer, right? Something like this could be a game changer. So we'll discuss that, and we'll also discuss Elastic Beanstalk. This is in the same category as CloudFormation, right? You saw CloudFormation, how you can use it to create your stacks, right? So Beanstalk is in the same category. It's quite different, right? It's quite different. The audience, the target audience, is quite different as well. But it's in the same category, because you can basically use Beanstalk to deploy your applications in a very simple manner, right? You simply have to upload your code, and Beanstalk will sort of give you an environment with that application deployed on the servers. Okay, so that's what Beanstalk is. But Beanstalk is more for developers, and CloudFormation is more for system administrators. Okay, so 5 services here. The 3 messaging services, Lambda, serverless computing, and then Beanstalk, which is a deployment tool, a platform. It's like a platform for developers. Okay, so interesting. This is a very interesting module. And in terms of time, what we're going to do is we'll probably spend 1 hour or slightly more than an hour on the messaging services, right? SES, SNS, and SQS. So especially SQS, right? Especially SQS, which I think is one of the more important services. Okay, and then maybe an hour on Lambda, and then the remaining time on Elastic Beanstalk, right? So today, given that we have just 1 hour, we'll only do the messaging services. All right, so let's get started. So we'll start with SES, right? Let's start with SES, and this is the messaging services. It's no longer called application services. Okay, so before we start, let's just understand what these 3 are, right? And also what messaging services are. What do we mean by messaging services? Okay, so SES is simple email service. SNS is simple notification service, and SQS is simple queue service. Okay, so email, notifications, and queuing. These are the 3 different services, right? And just by hearing those words, you can make out that these are messaging services, right? They all have to do with messages. Okay, and earlier they used to be called application services, which is not a bad category, because these services are normally used from our applications. Okay, so you may have an application, say an e-commerce site or a business application, right, like a CRM or a HRM, HR management tool. So those applications will use these services, right? So SES, for example, simple email service, your application probably sends out lots of emails, right? And instead of creating and managing your own email servers, right, or your own email infrastructure, you can use SES instead, right? So you can outsource the delivery of email messages to SES instead of trying to create and maintain that email infrastructure yourself. Okay, so that's the reason these are called messaging services or application services, right? They help you develop applications faster because you don't have to reinvent the wheel, right? So instead of doing these things yourself, you can simply use these services. You can get going faster, right? You can focus on your business application, your business logic, rather than this kind of infrastructural stuff, right? And it helps you get going faster. Also, it reduces your maintenance overhead, right? Because email infrastructure, for example, it's hard to maintain, upgrade, secure, right? So instead of getting bogged down by these things, right, you can simply outsource it to SES, SNS, and SQS. Okay, so that's the background. These are called application services because you use them from within your applications, right? They help you develop things faster. They help your maintenance overhead go down, right? So that's why application services. And of course, they're called messaging services because they're all to do with, all these services have something to do with messages. Okay, all right. Now, individually, let's look at these, right? So SES is email service. So it helps you send outgoing messages, outgoing email, right? Which is a very common thing for applications today, right? It's becoming less common, less important now because of mobile phones, right? But in the last decade, right, you know that emails have been very important, right? All applications send outgoing email, right? But managing email infrastructure is hard. Okay, so we use SES. SNS, simple note, which is actually it's a pub sub service, publish and subscribe, right? That's a pattern, publish and subscribe. And the way it works is you have topics, you have publishers sending messages into topics. Each topic can have subscribers, right? One subscriber can subscribe to multiple topics, right? And the subscriber can also choose what the delivery method is, right? So one subscriber may want to receive a message via SMS, right? Another via push notifications, another via email, right? So those kinds of delivery options are available as well. So SNS is basically a notification system which follows the pub sub model, right? A pub sub pattern. Okay, and then you have SQS, simple queuing service, and this is basically a way to loosely couple, right? Loosely couple components. If you have a distributed architecture, a distributed application, your components, let's say you have microservices, those need to talk to each other, and the best way of doing that is using queues. Okay, because then you have loose coupling. If one application, one component, the receiving side is slow, or if it is down, right, the sending side is not affected because it simply sends a message into the queue. Right, it doesn't have to wait for the other side to respond, right? And the problems with the other side don't get propagated to the sending side, right? So the queue acts as a buffer, highly reliable, highly scalable, very fast sort of service, right? Where your messages are stored temporarily for the other side to pick up as and when it is ready. Right? So that's what SQS is. Okay, all three are important. I think SQS is very important. SES can be very useful, right? And SNS is also becoming important because it can do push notifications, right? So in the modern world, mobile phones are becoming very important, right? And you may have an application, and using SNS, you can push messages to your applications, right? These could be Android applications, Apple phone, iOS, Windows, etc. Okay, so all three services are very important. SQS especially because of the emerging microservices paradigm, right? SNS because of mobile phones and push notifications, and SES, yes, because email infrastructure is hard to manage. Okay, so this is the agenda for this hour today. All right, so let's talk about the first one, right? The first one is SES. Okay, so I'm going to do the same thing, right? So we'll cover a few slides and then a demonstration followed by some Q&A. So let's get into the slides. Okay, so simple email service. All right, so what's happening here is that some of you may have experience with sending emails, right? I have experience with sending emails, and what I found is, we used to send it ourselves, so we had to create our own email servers, you may not know this, securing email infrastructure, right? There are two problems with email infrastructure. One is the security, right? Because people try to hijack your email servers for spam purposes. Okay, so they try to relay spam messages via your email servers, right? So it's very important to secure your email infrastructure. The other problem with the email infrastructure is that you need to know enough about this to sort of maintain the reputation of your email servers, right? So if you don't follow good practices, basically you should send emails only to people who ask for it, right? At a high level, that's the etiquette, right? That's the etiquette. But most people, most companies, for example, in developing countries, in India, for example, right? Many large companies, well-known banks, for example, they routinely flout, right? They get emails from dubious sources and they routinely spam people, right? Very aggressively. So if you do that, your email, there's a whole email infrastructure, the whole ecosystem of the internet there are mechanisms in which your reputation suffers, right? And your emails start going into spam. Okay, so if you don't follow good practices, right? Basically, if you try to send emails to people who don't want them, right? People start marking them as spam, and your reputation suffers, and then all your emails start going into spam. Okay, so that's another hard part about emails. Okay, so maintaining security, maintaining reputation, these things are hard. Okay, and it's not worthwhile for many companies. It is not worthwhile, trying to sort of do this on your own, right? Getting distracted by all this. You may not have the expertise, you may not have the time, you may not have the resources. So it's better that you focus on your application, right? And instead, and sort of hand over the emails to SES, because SES will take care of that for you. Right? It will take care of security, and it will enforce standards such that your email sending practices are sound. Okay, so that's what SES does. All right. So you can see here in this slide, what's happening is you have your application sending an email, right? And you don't send it directly to the receiver. You first hand over the email to SES, right? And SES is the one that initiates the email, right? And then via the internet, and then your receiver via the receiver's internet service provider sort of receives the message, right? So this is the flow here. You don't have to maintain your own email servers, right? Even though it seems to suggest, this diagram seems to suggest on the left side that the sender has their own email server. It's not required, right? I don't think this should be done. Although you can do it, your application, right, will directly make an API call to SES, right, and then SES will send the email via the internet to the receiver, right? So you have to specify the destination, the receiver's email address, and the message, right, and SES will ensure delivery to the receiver. Okay, that's what SES does. Okay, so the use cases are, marketing, right? Marketing is very controversial, though. Okay. Marketing is very controversial, mainly because of spam. Okay, mainly because of spam. The advertisers, they just want to, for example, I can give you an example. My bank, right? I have a bank. I have an account, and their service emails. These are legitimate emails which I want to receive. Their service emails actually go into my spam folder, right? They go into my spam folder. And the reason that happens is because the same banks, they spam people, right, very aggressively. They send out offers, loan offers, and things like that very aggressively, even to people who don't want such messages, right? So that's a controversial sort of aspect of email, right? But you can use SES, right? Even you can use SES for marketing email as well, right? But you have to follow SES standards, right? So you have to agree to their terms and conditions, right? Which would mean that you can only send email to people who want it, right? So you should collect email addresses responsibly, right? You should ask them, are you open to receiving messages from us, right? Even if you send them an email, you should always have an unsubscribe type of option so people can get out of that campaign, right? So those kinds of things you have to do, and if you don't, then SES can suspend your account, okay? Because marketing is a very sensitive topic. Spam is a very sensitive topic. It's a huge problem, right? Spam is a huge problem in the internet space. Okay, of course, transactional emails are better, right? They're better because these are already, these are customers, right? They've already signed up for your service, and you're sending them updates. For example, when you buy something on an e-commerce site, right? The e-commerce site will send you many messages for a single order, right? So one is an order confirmation, maybe the other is payment receipt, third is dispatch confirmation, fourth is delivery, fifth is, can you leave a review, right? So those kinds of messages keep coming for each order, right? So those are called transactional emails, and that's a good use case for SES, less controversial than marketing email. Okay, so these are the two major sort of use cases, and of course you have other things like notifications. You can also use SES for receiving email, right? But that's a smaller part of it. Let's just focus on outgoing email. Okay, now one more slide here, right? So this is the sort of some limitations, right? Some limitations on SES, because what you have to understand is email is a very sensitive thing because of spam, right? And SES will try and enforce certain rules to make sure that certain bad actors, right? You may not be a bad actor, but there are many people in this world, right? For example, a professional spammer may sign up with AWS, right, using a free tier offer, and on day one send a million spam messages, right? So to prevent against those kinds of practices and people, SES has certain limits, right? So when you start using SES, you are in what is called the sandbox environment, right? And you can only send 200 emails per day, okay? And you can only send one email per second, okay? All this is to deter spammers, right? All this is to deter spammers, okay? And then there are some other sort of limits, like only 10 MB per message, the size, right? And only 50 recipients per message. All these are not important, I think. But the main thing here to understand is that you won't be able to send large amounts of email right away, okay? So that's because you're in a sandbox environment. Okay, once you, and this is, the sandbox environment is there to help you test out SES, right? Once you're ready to use SES in production, you have to request for a sending limit increase. Okay, you write to AWS and explain what you're doing, why you're sending emails, whether you've understood their SES's terms of service, right? Basically, you have to agree that you will not be spamming people, right? So once you agree to all that, they will increase your sending limit, and you can then send many messages, right? Thousands of messages, maybe even tens of thousands of messages using SES. Okay, so this is what SES is. Let me show this to you, and then I'll stop for questions. Okay, by the way, just a quick look at our CloudFormation stack here, right? So you can see the create complete is create complete message, right? So you can also click on the output tab here, and you will see your sample PHP application. Okay, all right. You can also delete the whole stack, right? You can delete the whole stack with a single click. So any size, right? You may have a very complex stack. You can delete the whole thing using a single click. So it becomes easy not just to create stacks, but also to tear down stacks. Right? So this speeds up the work of a system administrator. Okay, all right. So let's go out and let me find SES. right? We find SES, and this is, you can see, in the messaging category. Earlier it used to be in the application services category. All right, so here let's find SES. It's the last option here. Okay, so this is the web console, right? The home page of SES, and before you do anything, right, you have to take care of identity management. Okay, identity management. So what you have to do there is first set up your domain. Okay, what domain are you going to use to send your outgoing messages? Okay, that has to be set up first. So basically, just type your domain, yourcompany.com or something like that, right? And create and click on this button, verify this domain, right? So there'll be a verification process where a message will go to the domain owner, right? So maybe you've registered the domain, so your email address will be on file, right? So you'll receive a message asking whether you're trying to sort of set up a SES account, right? So if you say yes to that message, then your domain is verified, right? You can see here this domain is actually verified. Okay, so the domain has to be verified, and why are we doing this verification? Again, because of spam, right? So SES has to take lots of precautions to ensure that spammers don't misuse the service, right? So that's why they are ensuring that the domain from which the mails go is verified. Okay, also email addresses, right? So you need to verify each email address. Okay, remember, we are still in the test phase, right? We're in a sandbox phase. So we need to verify each email address that you'll be using in the test phase. Okay, and these email addresses are not just email addresses that are sending email, they're also the email addresses which are receiving email. Okay, so all email addresses involved in testing, senders, receivers, CC, BCC, right? Everything has to be verified. And verification simply means entering your email address. The email address will receive a message from SES. You have to confirm that yes, this account belongs to me and I'm willing to participate in this SES test, right? So once you verify all that, once you confirm on that message, then this email address is verified, right? So you have to verify the domain from which you're sending email, and you have to verify all the email addresses that will participate in the sandbox environment. Okay, so these two things have to be done. Now once you do that, you can then start testing. So you can do a test email, right? For example, something like this. Yeah, so you have to use the same email, one of the emails in the verified list, right? So something like this, okay, and you can then send a test message, right? And you can verify whether this message is received or not. All right, so this has to be done. Now one more important thing is that we're not going to be sending messages from the web console, right? We won't be sending messages from the web console. We'll actually be sending messages from our applications. Okay, so when we test emails, this is fine. You can do this kind of test. That's fine, right? But you actually have to test from your application, because that's what you want to do later. Okay, so now I'm going to show you a sample piece of code, right? We've seen a sample piece of code with DynamoDB, for example, right? So same thing. I'm going to show you a sample piece of code, and I'm going to show you how you can use the AWS SDK, right, Software Development Kit, to sort of interact with the SES service to send outgoing messages. Okay, so let's take a look at this sample code here. Okay, so this is a Ruby program, right? Ruby is a programming language, just like Java or PHP or .NET. And this is a Ruby example, but you can do something similar in any language. Okay, because the SDK, the Software Development Kit, is available from AWS for all the major programming languages. Okay, all right. So what's happening here in this piece of code is that you have the SDK, the library is being included or required, right? Then you create an object called SES. This is an object of the SES client class, all right? And then this class has a method called send email, right? This is the method or operation that is used to send the outgoing email, right? And in this method, you have to supply the input, which is, the sender, right? Who's sending the email, to whom, right? To whom, and then the message itself will have the subject and the body, right? The body can also be, this one is in text, but you can also have the body in HTML, right? So you can have nice colored emails, right? Very professional looking. You can have CSS colors. You can have images. All those things can be done, right? So SES can be used to send not just textual messages, but also fully promotional marketing type of messages with full color and images. Okay, but this is the sample code which shows you how you can send an outgoing message using the SES API. All right. Okay. So you'll be testing like this as well. It's not enough to test from the web console. You have to test SES from your application. All right. Okay. Now let's say you finish your testing, right? You're clear. You know how it all works, right? You're confident. Your application is ready. Your code is good. Your UAT team has said okay as well, right? Everything is fine. Now you want to go live, but then remember the limits, right? So out of the box, you can only send 200 emails per day. Right? That may not be sufficient. You may want to send thousands and thousands of messages, right? So what you have to do is you have to go to this section, sending statistics, right? And here you have to click on this button here, right? Request a sending limit increase. Okay, so this is basically a ticket. You're creating a ticket. You're writing to AWS, and you're asking for an increase in the sending limit, right? And basically what you have to do is you have to explain, right, what what your whole workflow is, what is your objective, right? What do you do as a company, right? So all those things have to be supplied, right? So for example, if you say marketing, right? Marketing is sensitive. Then you have to supply your website so that they can look at your website and make out what you're all about, right? You have to agree to their service terms and user policies, right? Basically, don't spam people. And this is what it means, basically. Okay, you should have a process you should normally send emails to people who request emails from you, right? That's the best practice. You should have a process for bounces and complaints, right? So if there's a bounce or a complaint, so if someone says, hey, stop sending spam to me, right? They may mark your email as spam. So then you should have some process, which is basically don't send that email to the same person again, right? Someone says you're spam, don't send emails to that person again, right? Which is what these banks, in my case, right? Which is what my bank does, and therefore all the bank's emails go into spam. Okay, so these are sort of things that you must understand, that you must accept, right? Explain what you're doing, and you can then send a request to SES, right? Hopefully it'll be approved, and then you can send large email volumes, right, in a legitimate way, in a clean way, using SES. Okay, all right. So that's SES. Let me stop here. Let's see if you have any questions on this first service, the first messaging service. All right, so let me know if you have any questions on SES, and next I'm going to talk about SNS, right, and then finally we'll talk about SQS. All right. Okay. So okay. Let me move ahead. Right. Let me move ahead. Let's talk about the next service, and the next service here is SNS. All right. SNS. So SNS is simple notification service. Okay, and this is what is called a pub sump service. pub sub, it's short for publish and subscribe, right? Publish and subscribe. And this has been, a known architectural pattern, right? And SNS is an implementation of the pump sub architecture, right? And what happens here is you have topics essentially, right? You can have many topics, okay? And on the one side you have publishers, right? So these are say some users, some individuals, but often these are applications, right? For example, CloudWatch, right? CloudWatch is an application or a service which can publish messages to SNS topics, right? So that's how we receive notifications from CloudWatch, right? But it need not be CloudWatch. It can be anything else. It can be some application of your own which publishes messages to the SNS topic, right? And you have many topics. One application can publish to many topics, okay? And on the other side, you have subscribers, right? And these can be people, individuals, developers, for example, or support personnel, right? And they can subscribe to one or more topics, right? And when they subscribe, what they're saying is, look, if any message is published into this topic, let me know, right? So they want to be notified whenever a message is published on that particular topic, right? And of course, you can subscribe to multiple topics as well. All right. When you subscribe, you also define how you want to receive the message. Okay. So you can say, okay, send me an email, or someone may prefer an SMS. So you may say SMS, right? And in the next slide, we'll see that you can also receive messages via push notification, right? So to your mobile phone application or to your tablet application, right? So you can receive push notifications as well, in addition to email and SMS. All right. Okay. Now, sometimes the subscribers will be applications, right, or services. Okay. So the subscribers need not be people. They need not be real people. It can also be applications. For example, you may have a ticket system, right? A trouble ticket system. And what you want is, whenever there's a problem with, say, one of your systems, instead of sending a notification to a certain person, you prefer that the message be sent to the ticket system, right? Because the ticket system helps you manage the issues better, right? You can track them better, you can notify people better. So you want the message to be sent not to a person but into the ticket system, right? So that's why the subscriber, your application, your ticket system can also be a subscriber to an SNS topic, right? And the application will provide an HTTP or HTTPS endpoint into which the SNS will send a message. Okay, and thereby create a ticket automatically. All right, so all these things are possible. Of course, you can also have SQS, right, which we'll talk about later. So you can also have a queue as a subscriber to an SNS topic, and basically, there'll be another application on the other side of the queue which will process the message. Okay, so basically the point is, it's pump sub, right? The subscribers can be people or applications or other kinds of services, right? And the subscriber can subscribe to multiple topics. Publisher can publish to multiple topics. Each time a message is published, all the subscribers will receive the same message via their chosen delivery method. All right, okay, so that's SNS. All right, now this is the push notification side, right? So remember, a person can receive a message, the subscriber can receive a message via email, SMS, or push notification, right? So the push notification is actually, you need to have an application, right? You need to have an application, say for the Android platform, or the Apple platform, or the Windows platform, right? So you have to sort of basically the way you implement this is you can use any of these platforms, right? So Amazon device messaging is Kindle, right? Apple is iOS or the Mac. Baidu is China's Google, right? So they're like Google. So they have an Android-like platform, I guess, right? So that's the Baidu Cloud Push. Then you have Google Cloud Messaging, which is Android, and then you have Windows phones and Windows laptops and computers as well, right? So basically, you have to have an app for these one or more of these platforms, and then you can configure the details in such a way that whenever a message is published into a topic to which the application is subscribed, right? Let's say your Android app has to be subscribed to an SNS topic, right? So whenever a message is published to that topic, all the application users, right, all the Android app users will be notified via push notification, right? So this is a great feature. Okay, it's a great feature, especially given the increasing importance of mobile phones, right? So SNS can do this for you. It can basically send push notifications to millions of Android app or iOS app users, right? In a very simple manner, right? Imagine trying to set this up in your own application, right? If your application had to send push notifications to millions of users, right? That would be a lot of work. But here with SNS, it's just a matter of configuration, right? You just configure your app to sort of link up with SNS, right? And then you simply send in the messages into SNS, and all these subscribers, millions of them, right, if required, will receive push notifications. Okay, so this is an important part of SNS. All right, so okay, all right, so let's stop here. Let's stop here. Okay, let me show this demonstration to you, and then we'll stop for questions. Okay, so going back out and from the home page, let's find SNS. This is here under the messaging category. Okay, so here, like I said, first you have to create a topic, right? You have to create a topic. You can have any number of topics. So, for example, server down, right? Server down can be one topic, right? So it's very simple to create a topic. Once you've created a topic, you can publish, right? You can publish to the topic, something like this. Right? And normally you won't be, publishing like this, right? It'll be some kind of application that will publish a message. For example, CloudWatch publishes messages via SNS, right? That's how you send it sends out notifications, or it could be your own application. It could be some kind of a custom third-party monitoring application, right? So it could be anything which publishes messages to a topic, right? So that's how you do it. Now, also the other side of the topic is going to be subscribers, right? So you have to subscribe to a topic. Okay. Now here I'm subscribing using the web console, but normally you have to sort of handle the subscriptions yourself. Okay. So you may have to create another application which uses the SDK, the AWS SDK for SNS, right? And manages subscriptions that way. Okay. But here we're just testing using the web console. So, for example, you may say, okay, this is an individual who's subscribing, right? An individual. So the individual can say, yes, I want to receive an email message whenever a message is published into this topic, right? So the user has to specify the email address on which the message will be received, right? So as soon as you subscribe, the confirmation message is sent. The user confirms the subscription, and from that point onwards, any message published to the SNS topic will be sent to this email address. All right. Okay. Now you may be a user who prefers SMS, right? Instead of email, you prefer an SMS, so you can supply a phone number here, right? Now this works only in the US at this time. Okay. SMS delivery is only available in the US at this time. Okay, because I think it's more to do with telecom. Telecom companies are very hard to work with, right? And then AWS may be facing that kind of problem, or it could be some kind of cost negotiation type of issue, right? Or they've not gotten around to working on this. Okay, but the fact at this point is that SMS is only available within the US country, right? So there's only at one country, and it's not available elsewhere. All right, but this is an option. Okay, so you can subscribe and say and receive the delivery via email or via SMS. Okay, this is for people. Right? This is for people. Now let's say you have your ticket system, right? So you want a message to be sent to your ticket system so that a ticket can be created for certain kinds of topics, right? Certain kinds of messages. So then you can choose HTTP, right, or HTTPS endpoints, and here you'll supply the URL, the complete URL of your ticket trouble ticket system. Okay, so this way an application can subscribe to a topic as well. Okay, all right. Now let's talk about push notifications. Okay, so what you have to do for push notifications, first of all, is that you go into applications, right? So these are basically your Android app or iOS app, right? And create an entry here, right? So you have to give a name here. Let's say this is your Android app, right? And you have to choose the right platform. So this is Google Cloud Messaging, because that's what has to be used for an Android app, right? And here you supply the API key. This API key you will find in your Google Developer Console, right? So if you're an app publisher on the Google platform, on the Android platform, then you have to have a developer account, right? And if you log into your developer account, you'll find this API key. So you find it there, and then you copy and paste here, right? So this way, you are basically authenticating yourself. You're saying, look, I'm a legitimate developer, right? I have a developer account with Android, and so basically it's a security measure, right? Basically, you're proving that this app actually belongs to you. Okay. All right. So once you create an application like this, right? You create an application entry like this. All right, then you can go to any topic, example server down, right? And then you can subscribe that application, right? You can subscribe that application. This will be the ARN of your Android app, right? So once you create that entry there of your Android app, you supply the ARN, and then the subscription is complete, right? So this way, all your Android app users, and there could be millions of those, right? As soon as you publish a message to this topic, all your users will receive a notification. Okay, that's a very, very powerful thing, because you don't want to, recreate or reinvent the wheel around this kind of capability, right? And you can imagine how important push notifications are in today's world, right? So this is a great feature. It's a great feature. It can speed up your application development to a great extent, right? And also make it much easier. Imagine maintaining and troubleshooting the pub sub service if you've created it from scratch. All right. Okay. So this is SNS. Let me know if you have any questions on SNS, right, or even SES, which you've seen before. All right, so let's discuss SNS, and then we'll discuss SQS. We'll conclude the session today on that, right? And tomorrow we'll talk about Lambda and Beanstalk. Okay, so this question, Rao, how do you send notifications like SMS, email, etc. in bulk? So you can use, you can use the CLI, right, on the SDK, right, and write your scripts, your applications, right? So you can send them in bulk. There might be some bulk operations as well. Okay, so check out, well, not check out, but find or review API calls that are batch, that are batch mode operations. Okay, so there might be some operations or methods in the SDK documentation where you can send stuff in batch. All right, I'm not sure about that, but you can check that like a little assignment, right? You can go and see if there's a batch mode for sending, publishing messages in bulk into SNS, right, or sending emails in bulk using SES. Right, but even if they are not available, you can certainly write scripts which will send lots of emails, right, in a kind of a batch. And what's your use case, right? If you explain your use case, it'll be better for others can also understand, right, why you want to send notifications in bulk. All right, okay, folks. So now let's talk about the third messaging service, right, in our in this module, and this is SQS. Okay, so simple queue service. All right. So the way this works, and the whole reason for this, right? Why are queues important? Queues are a very old idea, right? They're not new at all. They're not an AWS invention. We had queues, going back decades, right? I remember there used to be a product called IBM MQ series, right? It still is, of course, right? And these products were very expensive, from companies like IBM, and they were mainly available to very large organizations, right? Uh, um, so it was not democratic, right? They were not accessible, but the idea has always been there, and it's always been a very good idea. Right? The idea of queues has always been there. And the whole idea is that if you have two, say, applications, right, communicating with each other, or two components in a distributed application, say two microservices talking to each other, right? So what happens is, if the sending side has a hard coupled communication with the receiving side, right? Let's say synchronous API call, right? So what happens there is that if the receiving side is down, let's say it is overloaded, or it's down for maintenance or something like that, right? Or it could be slow, right? It is overloaded, therefore it is slow. So the receiving side is not able to respond quickly enough, right? Or not respond at all. So the sending side gets affected, right? Because it's written in such a way that it's hard coupled, and it has to wait for a response. If it doesn't receive a response, it gets stuck or something like that, right? So the problems on the receiving side get propagated to the sending side. Right? This is the problem with the synchronous type of communication, right? So instead, you can use a queue, which is basically a temporary storage, right? It's a temporary storage, highly scalable, highly available, right? You can send data at a very fast rate as well, right? So the throughput can be very high as well, and so you can have a queue, right? Instead of a synchronous type of communication, have a queue between these components of on these applications, right? That's always better. Okay, this is called loose coupling. It's always better to do things this way. Okay, because let's say the receiving side is down, your sending side doesn't care, right? Your sending side simply puts in a message into the queue and moves on, right? Goes on with the rest of the processing, and the messages can get accumulated in the queue, right? It's like a buffer, temporary storage, very safe, right? Very safe. And when the receiving side is up, right? Maybe it was down for maintenance, right? Maybe it was overloaded, but now it's functioning normally. So then the receiving side can sort of pick up the messages and start processing them, right? So this is a great way. It's a great architecture, right? You should think about using queues more and more in your designs. All right. Okay. The other thing about queues also is that it allows for multi-threaded, right, multi-server type of reads and writes, right? So for example, on the sending side, it's not just one component or one server which is sending messages, right? You can have hundreds of servers pumping messages into the queue, right? And the same thing on the receiving side. It need not be one server, right, or one process or one thread. It can be hundreds of servers reading from the same queue, right? So it's designed for parallel processing, and you can have any amount of volume and any amount of throughput, right, going through the queues. So it's that kind of service. Okay, it's that kind of a service. A lot of the magic happens behind the scenes, right? Highly durable, very fast, very scalable, right, and very high throughput. Okay, so imagine thousands of messages per second, right? That kind of volume and throughput is what you should be thinking about, right? So say with Amazon.com or Flipkart.com, right? That kind of volume is possible, and it's probably routine as well. Right? So that's where you can use queues. All right. Now, how does it work? Right. So how does it work is interesting, and this bit you have to understand very well. Okay, because you also should understand the difference between SNS and SQS, when to use which one, right, and how does the operation of SQS differ from that of SNS. Right? So in SQS, what happens is you also have the publisher and receiver. Right. You have the same thing with SQS as well as you have with SNS. However, what happens here is the publisher sends a message into the queue, right? And then the consumer has to pick up the message, right?
is to pick up the message, and once you pick up the message, you have to delete the message from the queue. Right? This is not what happens with SNS, right? But here the consumer, right? And remember, there can be many consumers, there can be many servers reading from the same queue, right? So one of the consumers will pick up the message, process the message, right? And at the same time, we delete the message from the queue so that others don't pick it up, right? Other consumers don't pick it up from the queue, right? So this is very important to understand, that the consumer has to pick up the message and delete. Okay, it has to delete the message so that there is no duplicate processing. All right. Also, so that the message is removed from the queue, right? And the queue doesn't have to store it and worry about it. Okay, so it should remove it, delete it once the message is processed. All right. Okay, so quick word about pricing, and then we'll look at the demo. So pricing is, you can see, it's quite low cost, right? So 1 million requests are free, and this is, I think, not even under the free tier. Even after the free tier, 1 million requests are free per month, okay, per month, and thereafter there's $50 or something like that, right? This is important. The maximum size of a message can be 256 KB. Right? Earlier it used to be 64 KB. Recently they made it 256 KB. You can go beyond it, right? There are other ways of doing it, but normally the maximum size of a message is 256 kilobytes. All right. So now let's look at a demonstration. Right? Let's look at a demonstration, a quick one. All right, so what I'm going to do here is, let's imagine a scenario where you are an e-commerce company, right? And you have a front end, a customer front end, right? Something like this, okay? Let's say Amazon.in, right? So this is the customer front end, and you will, place your order through this front end, right? And then, so this application becomes our publisher, right? So we want this application to push messages into a queue, and then on the other side of the queue, you'll have some processing applications, right? Let's say some order processing applications, some inventory applications, some accounting applications, right? So those kinds of applications will be on the other side of the queue. Okay, so let's imagine that scenario. Now here, what I'm going to do is start with creating a queue. All right, let's call this orders. All right, let's think of these as e-commerce orders flowing in at a very rapid rate, right? Very high volume, very high throughput into this queue. Okay, on the other side, you have processing applications or components picking up the orders. All right, so now we have a queue. So the sending side or the publisher side will basically send a message, right? So this is how it is done. So let's say this is order 1, right? And maybe this is a Google Pixel phone. Right? And you can also have other information about the order. All right, you can optionally have message attributes, right? So message attributes are optional, okay, and they help you to sort of process the message, or to decide whether you want to process the message just by looking at the attributes. You don't have to open the message body, right? So using attributes can be faster when you want to evaluate what to do with the message. Okay, so for example, you may have an attribute called priority, right? You can have up to 10 attributes, I think, right? So you can have a message body like this one, right? And then one or more message attributes, right? So this is your the publishing side, the application on the publishing side, which is sending a message into the queue. All right, so you get a message ID back, you get a response, right? You have to wait for the queue to tell you that yes, we have created the message, right? So you have to wait for it. There could be a bit of latency, but you wait for it, make sure that the message has been delivered into the queue. Okay, so it's a synchronous call. You wait for a response, and you get back things like the message identifier and certain other attributes. All right. So now a message is available in the queue, right? And it's waiting for someone to pick it up. Okay. On the other side, you may have a large number of servers. You may have an auto scaling group as well, which is waiting for messages, right? So what happens on the other side? Okay, on the other side, you have this operation, view and delete, right? So you have to view and delete. Okay, and what you do is you do a polling. Okay, it's a polling that you have to do, and the reason for the polling, right? What it basically means is polling. What it means is, you have, remember, you have multiple servers processing from the same queue, right? So each server will poll, right? Each server will poll, and when you poll, right, for 30 seconds, right? This is the polling window, right? So if you're shown a message, right, in your window, then the same message is not shown to any other server which might be reading from the same queue. Okay, so this is how it works, so that there's no duplication, right? So this message is shown to me, it will not be shown to anybody else. Okay, so that there's no duplication. All right, but only during this polling window, right? If I don't do anything with this message, right, I don't do anything with this message, so now there's no guarantee, right? Now this message maybe, this order may be shown to someone else. Okay, so that's the point, that whenever a server is polling, during that window, if it sees an order, right, it can look, you can look at the details, you can look at the message attributes, for example, right? Maybe you're a server which is that is dedicated to high priority orders, right? So you look at the message attribute, you find a high priority order, you decide you're going to process this, right? So you can pick it up, right? You can pick it up, and as soon as you pick it up, make sure that you delete the message, right? You must delete the message, right? Otherwise, the message will remain in the queue and may get processed by someone else. All right. So that's the whole point of polling. It's basically to sort of handle the concurrency, right? Many servers are polling at the same time, so a message shown to one server should not be shown to other servers, right? For a short window. All right. And if your server is picking up the message, it should delete the message from the queue. Okay. So viewing and delete go hand in hand. All right, so this is at a high level how a queue operates, right? So you have a queue, you have a publisher pumping in messages, right? Many servers pumping in messages at the same time, very high volume, very high throughput. And on the other side, you have, a very large number of servers, again, maybe an auto-scaling group, which is reading concurrently, right, from the queue, and all servers have to do polling, okay, so that duplicate processing does not happen. And if you have any messages, if you're processing them, you have to make sure that they are deleted from the queue. Okay, this is how queues work. Now I'm going to show you some sample code once again, right? Some sample code once again, because again, you're not going to be using queues from the web console, right? You have to use them from your applications, right? Like this application. Okay, so if this is your front end, the customer is creating orders here, right? So this application will be writing into the queue, right? Similarly, you'll have some other application, the processing application, the inventory application, which has to read from the queue. Okay, so that's why. Let's take a look at some sample code here. All right, so this is for sending messages, right? For sending messages. So you can see here, it's the same thing. Require the SDK, create an object of the client class, and then use the send message operation, right? And here you have to specify a few things. One is the queue URL. Okay, queue URL. This is the unique identifier of the queue. Okay, because you may have many queues, so you need to say which queue we are talking about here, right? So the queue URL you can easily find here. It's the property of the queue, right? So you can easily find the queue URL, and then in your application include the queue URL, right? And then the rest of it is the message body and the message attributes, right? So this is the same as what we've done in the web console, right? Except we are doing this from our applications code. Okay, so supply the message body, supply one or more message attributes, right? And you supply the queue URL, and this operation will create a message in the queue, right? So this is how your application will publish messages. All right, now you can also see on the receive side, right? So this is the second application or component, right, which has to receive the message. Okay, so here what it does is it uses another operation called receive message, right? And it supplies again the queue URL, which queue you want to receive messages from, right? And certain other attributes like how many messages you want to see at a time, because remember you're polling, right? So you may be shown lots of messages. So so you're saying, look, I can process only 10 at a time, so right? So that's how it works. And when you receive a message, you may receive more than one message, right? Because in the queue there could be thousands of messages. So if you receive more than one message, you have to sort of go, in a loop, right? You run this in a loop, and for each message, you do some processing, right? So here I'm just displaying the message details, right? But you would do some processing, maybe store the message in a database or something like that, right? And then you have to delete the message, right? Remember, view and delete go hand in hand, right? So you have to remember to delete the message, right? And there you supply the queue URL once again, and then what is called a receipt handle, right? The receipt handle is visible when you read from the queue. Okay, so this is how you view and delete from your application. All right, okay, so let's stop here and let's see if you have any questions on SQS. All right, any other questions, on SES, SNS? Now that you've seen all three, right, you should also think about a comparison, especially SNS and SQS. What is the difference, right? When do we use which one? Those kinds of things you have to think, right? As a solutions architect, these are the kinds of issues you have to deal with in real life projects. All right, so let's look at these questions. So around SQS, what's the type of message persistence, type file or DB? I don't think it's DB. I don't know, right? I don't know for sure, but I don't think it is DB. Okay, and also it's distributed. Okay, so it is a message is stored on multiple servers. So that's why it's durable, right? It's the message durability is high. Okay, could you show us queue controls, like how to stop consumption? What's the difference between SQS and Kinesis? How to stop consumption? No, but if you explain what your use case is, that's much better, right? I don't know what you mean by stop consumption, right? I mean, I have some sense, but if you explain it more, that'll be better. And what's the difference between SQS and Kinesis? Kinesis is more for streaming data. Okay, it's more for streaming data, and SQS is more for longer term storage, right? SQS is more of a buffer, temporary storage, but longer term storage. Okay, Kinesis is more streaming, real time, live data. But it's a good question. Let me also look this up. Maybe there's some good documentation around this. Okay, so I think these kinds of questions you'll find in the FAQs, right? So let's see what it says about this. Yeah, so this is the question. Yeah, so you can read this, right? But I think it's a good question. Maybe you also have to sort of evaluate this, try it out, and see which one works better for you. But it seems to be saying that yes, it is for real-time processing, but it provides ordering of records, right? It provides ordering of records. SQS also is normally FIFO, right? Normally it's FIFO, but it's not guaranteed. Okay, so that's one difference. Ordering of records. As well as ability to read and replay records in the same order. That's something that SQS cannot do at all. Okay, ability to replay is not there with SQS. Okay, and it looks like from one stream you can have multiple applications reading, right? Whereas with SQS, one message has to be read only once, right? So So these are the differences on the face of it, but I think depending on the use case, right, you have to sort of try it out and see which one works better. It's not a clear-cut answer in my view, right? It's not a clear-cut answer. Okay, so okay, so on the first part, could you show us queue controls like when to stop consumption? So if you're, say, during maintenance or when the end system is down, I don't want to generate errors. Now, what errors? See, and which maintenance, right? So if your consumption side is under maintenance, then there's nobody reading the queue anyways, right? And if your publishing side is down, then there's no messages being generated, right? So what errors, right? What errors are you concerned about? Okay, the messages are in the queue. Okay, they'll remain in the queue till someone reads them. Okay, all right. So yeah, you can let me know. In the meantime, let me look at the next one. Babita, how does this work for application where messages are pre-planned and not created every time? Yeah, but which one, right? Which service, right? Which service are you referring to? And also, again, if you tell me your use case, right, that'll be better. Yeah, so that'll be better. So let me come back to your question. Gajendra, would we have access to recorded classes for the next few years? I think so. They say lifetime access, right? They say lifetime access, so I think so. But you can check with support, right? So I'm just an instructor on this platform. Okay, so I don't know all the details, so you can check with them directly. I think. All right. Okay. So So coming back to this question, where we generate messages for other applications to process SQS. Okay. So if they're pre-planned and not created every time, so it doesn't matter. See, you're right in the sense, it's better for situations where messages are exchanged on a frequent basis, right? And you don't have loose coupling. So it can work in the same way, right? It can work in the same way, right? Even if messages are not frequent, right? If they're not frequently generated or whatever, right? It can work in the same way. So the SQS queue acts as a buffer, between the two sides. It can continue to do that. You can also handle this messaging in a different way, right? You can also avoid SQS as well. Right? You can avoid SQS as well. For example, if you have batch messages to be sent to another application, right? You can maybe send a file, right? For example, for batch messages, you can set up a simple file-based transfer mechanism as well, right? So yeah, so it's up to you, right? It's up to you. SQS can work as well. Right? Okay. Okay. Next question. Any authentication in order to send messages into queue, else anyone can push in others' queue? Yeah. Of course. Yes. So you need to have your application, right? Your applications, both of them, right? Publisher and consumer, right? Both applications need appropriate permissions. Okay, and that we will see in IAM. We will see this in the IAM module. All right. So yes, certainly, right? Without permissions, you can't read or write from the queue. All right, folks. So I think we are almost out of time as well. So what we'll do is, we'll end this session for today, right? So we'll stop here for module 8. Tomorrow we'll look at Lambda and Beanstalk, right? but let's also do this review. So those of you who want to leave, please go ahead, right? But if you want to discuss, if you want to hang around for this review discussion, right? There's a bunch of questions here. If you want to hang around for that, that's fine as well. Okay, so let's end today's session, right? And let's start the review process. All right. Okay. So okay. So let me answer this question, and then we'll go to this other sheet. Okay. So Sashi. You have to choose a separate entity to control processes like push notification, email, and SMS. Yeah. So my question is, what is the modular development provided by other microservices provider, or go with Amazon? Okay. No. So look, look, SNS is what is called a pump sub, right? Pump sub service, right? And it is modular. Okay, it is modular. It is already modular. Right. For example, SNS is not giving you SNS, SQS, SCS features altogether, right? It's only giving you multiple ways of delivery, right? So the subscriber, right? The subscriber can choose delivery options, right? From email or SMS or push, right? So it's not. I mean, it's just a delivery option, right? The SNS service itself is quite modular, right? It doesn't have too much of features. Okay, so that's my first point, right? So I don't feel the need. I don't see the need to sort of break it up further, right? I don't think there's any need for it, right? Okay. All right. And the second question is, if you adopt AWS services for these apps, then how much solutions actually have to depend on business support, which is $100 a month? Oh no, I don't think so, right? I don't think most people look. If you're a large company, right? Large companies like to have paid support, right? Why? Because the stakes are very high, right? If something goes wrong, right? If something goes wrong, you're always afraid, right? So if something goes wrong, will I be able to speak to somebody and get it fixed? Because billions of dollars are at stake, right? If you're, let's say, in a bank, if your ATM software is not working, right? Customers are not able to take money out of their ATMs, right? That's a serious issue. So you need to have paid support, right? So stakes are high, stakes are very high, right? So all large organizations like to have paid support, right? But if your company is not like that, you don't need to have paid support, right? For example, I have been, for 8 or 9 years, right? I have never contacted, okay? I've never contacted AWS for any kind of support. Never needed it, okay? Never needed it. But admittedly, I have used AWS mainly in a startup kind of environment, right? Startup and medium organizations, right? But I've never needed it because it always works as advertised, right? You don't need it normally, right? But unless you're a large company, okay? And that's more of an insurance, right? When you take support, you're basically going for an insurance. If something happens, I should have somebody, right? It's not really for help. It's for insurance purposes, for safe, for feeling safe. Okay, all right. So I don't think you should worry about it. I don't think you need support. All right. Okay. So now let's look at these questions. Right. So I think it's a good bunch of questions, and based on practice, right? Which is good. Okay. So Shyam, I hope you're here, right? Shyam, I hope Shyam is here. Okay, all right, okay. So, yeah, I was just looking at your names, but I couldn't find your name. Anyways, all right. So let's discuss these one by one. Maybe we'll spend 15-20 minutes on this, right? Okay, so edge location is basically cache servers, it's small. Let's say these are small data centers, right? Small data center. Okay, all right, okay. Yeah, so these are small data centers, right? And these have cache servers, okay? And the locations are major cities. Okay, this is what it is. Now, why is it like this? You know, why do they do this? Because edge locations together, right? Together form the content distribution network. Okay, CDN, content distribution network. And the whole purpose of this is to serve content faster, right, with low latency. Okay, to serve video and similar content, okay, faster with lower network latency. Okay, because video, you know, if you serve video from far away, let's say you are in India, the server is in the US, right? The video will take a long time, so it becomes a bit slow, right? So it's better if the video is near your location, right? So if you serve the video from the edge location, right, hopefully the network distance is small, so the latency will be less. Okay, that's what these edge locations are for. All right, but these are cache servers. So the first time someone looks at the video, it will be slow. Second time you look at the video, right, or second time someone else looks at the same video, the video is already stored in the edge location, then it will be faster. Okay, so it's not like all the content is stored in the edge locations. It's a caching server. So someone has to use, you know, that content. Someone has to view that content, then it gets cached, right, and then it becomes faster for people in that near that edge location. Okay, all right. So that's what that is. You have to use, you know, to use edge locations, you have to use a service called CloudFront. Okay, so the name of the service is CloudFront. So you can use CloudFront along with, you know, your rest of your stack like EC2 instances or S3 buckets, and this way you can sort of have a CDN working for you. All right. Okay, next one, RDS, how do we enable the master and slave feature in a free tier? Is it possible in free tier? Yeah, I'm not sure. Let's see. So I think, you know, you have X number of hours. You have X number of hours in the free tier, right? So maybe that includes yeah, it's not clear, right? It's not clear what they are offering here. Look, you know, I think it's 750 hours per month of database usage, right? So it doesn't matter how many databases you have, right? So maybe you have one primary, one secondary, right? It'll still be covered, I think. So my guess, right? My guess is you can also, you know, let's search on the forums, right? So RDS multi-AZ. Is it on the free tier? Let's see. Oh yeah, okay. So it's 750 hours of single AZ micro instance. All right, so here it is. It's clear, right? It's clear here that it's only 750 hours of single AZ. So single AZ only, right? Single AZ only is under free tier, right? Not multi-AZ. Okay, but you know, it'll be very small cost, right? You can just experiment with it and immediately remove it, so you'll be billed for an hour's worth of usage, right, which is very small. Okay, so the cost is not high as long as you delete it quickly. All right, okay, how to enable it? Just say yes. Just say yes to you know, just say yes to let me delete this. You just have to say yes to multi-AZ. Okay, so go to RDS. Go to RDS here, and when you create an instance, or when you know, even if the instance is already created, right, you'll find there's a field there. Okay, there's a field there, something like this one. See, multi-AZ deployment, right? So right now you can see here, right, you normally say yes, no to this. Okay, normally say no. But if you want to change it to multi-AZ, simply modify the RDS instance and say yes to this, right? That's it. Okay, that's it. All right. So so basically, to enable, simply say yes to multi-AZ deployment option, right? Use the modify option to edit this configuration, right? Also remember to apply immediately. Okay, there's an option when you're modifying the RDS instance configuration, right? Apply immediately should be checked so that the change happens immediately, right? If you don't check this, then the change may happen during a maintenance window, right? It's for immediate change. All right, so that's how you change it. All right, okay. This one, a demo on using a private subnet for creating an RDS instance instead of using the default VPC, which is very open. Yeah, okay. Not covered in any demo, but supposed to be done later. Yes. So I think this will take a bit of time. All right, this will take a bit of time. Maybe we can do it in the last module. All right, but look, I'll tell you the steps now. Okay, I'll tell you the steps now. So what you have to do is you can create scenario 2 VPC. All right, this has one public and one private subnet. All right, then create a second private subnet. All right, this has to be done manually. Okay, this has to be done manually, and make sure this private subnet is in a different zone to the first private subnet. Okay, why? Because RDS for multi-AZ, right, wants two different zones. All right, so that's why the second private subnet has to be in a different zone from the first private subnet. Okay, very important, very important. All right, then launch the RDS instance. All right, choose the VPC, choose, right. You also have to create a security group, right? Create an SG for the DB server, right? With appropriate rules in this VPC, right? In this VPC, and then launch the RDS instance. Select your VPC, select your SG, right? So these are broadly, these are the steps. Okay, broadly these are the steps. But I agree, we'll probably, we need a bit of time. This needs about 15-20 minutes. Okay, so so maybe in module 10. All right. In the meantime, you can try this, right? Give this a try. See what problems you face. Right? You can also, write to support. Okay, if you're trying this, if you're facing any problems, just write to support, and they will get back to you. All right. Next question. Demo on set up the RDS, say MySQL Oracle on private subnet. Yes. Access it from EC2 instance. Yes. Also, can we access it directly? Not sure if this is possible. Yeah. So again, the same. It goes back to the demo. So we need more time for it. But yeah, you can certainly access it, right? Access from EC2. Sure, this is easily possible, right? So what you can do is this EC2 should be in same VPC. Okay, you can maybe create a scenario 2 VPC, right? EC2 should be in the same VPC. It can be in this public subnet, right? It can be in the public subnet or the private subnet, right? It can be in either one, but it'll be able to talk to the RDS instance quite easily because it's in the same VPC. All right. Your DB security group should allow requests from this server, right? So that's something that I guess we have to see. These are a little bit tricky. These are little advanced topics, right? I think we should do it, right? We should do it. I should find some time for it. But yes, your DB security group should be, created in such a way that you allow requests from this server. Basically, you can mention the EC2 instance's private IP address as the source IP, right? So here, your source IP can be private IP of EC2. Okay, so this way you can allow access from your EC2 instance. All right, and the third question is, can we access it directly? No, right? You can't access it directly, not directly. Okay, because it is in the private subnet, right? So if it's in the private subnet, there's no network path, right? There's no way to reach the private subnet, right? The only way is you can jump, right? So you can connect to something in the public subnet, right? Maybe an EC2 instance, and from there jump to the RDS instance, right? You can do something like this, but or you can use VPN, right? Or you can use VPN. VPN is always possible. Okay, VPN is always possible, but otherwise you have to go indirectly from the public subnet to the RDS instance. All right. Next question: what's the difference between RDS snapshot and replica? Okay, so snapshot is point in time, right? It's a point in time as of that time, right? Replica, and it is just storage, right? It's just storage, backup. All right. Replica is a server, right? You can query it. You can query the server. Okay. By the way, there are two replicas, right? So there are two types of replicas. So multi-AZ, right? Multi-AZ option where there's replication, right? Where there's replication. This is one option where you have a standby server, right? You have a standby server, but it's a server. It's not just a backup, right? It's a server, and replication is ongoing, right? Replication is ongoing. It's not a point in time, right? It's ongoing. Okay, and the read replica is different. Read replica is actually a real server. Okay, real server. You can query this. You can actually use this server. All right, and here also replication is ongoing, right? It's not a point in time. All right, okay. So which one is used on what occasion? So snapshots for backup. Okay, snapshots for a backup. All right, because say your database gets corrupted, right? So you need a backup. All right. Multi-AZ is for high availability, right, or fault tolerance. So if your primary fails, primary zone fails, right, it'll fail over, right? Multi-AZ, automatic failover to standby, right? So you get high availability. All right, and read replica has multiple uses. Okay, read replica has multiple uses. This can be for scalability, right? You can scale your read load at least, right? Also, it can be for DR. You can also use it in some ways for HA, right? HA as well. Okay, and also these can be considered backup as well. Okay, but they're quite different. Okay, all these options are different. They're very different. Normally, you should have snapshots. Okay, normally you should have snapshots at the minimum. Okay, at the minimum, have snapshots. Okay, all right. Add multi-AZ for HA, right? If cost, if cost permits, basically, cost is not a constraint, right? And then add read replicas again for scale and HA and DR, right? Again, if cost is not a constraint, because remember, your cost goes up with read replicas and multi-AZ, right? Not so much with snaps. Snapshots are cheap. They are just S3 storage, right? Read replicas are real servers, so they'll be expensive. Okay, so snapshots are cheap, replicas are expensive. Okay, all right. What to delete and what not to delete? You already billed $1.5 even after all the cleanup. You used Oracle. Yeah. So you can compare. Look, what you can do is you can once after cleanup, right? After cleanup, uh, 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 compare the next day, right? The next day's bill to today's bill, right? There should be no increase. There should be no increase, right? That's how you can know if there's something which is still causing billing, right? That's how you know. Or you can visually inspect, right? You're going to say RDS or EC2 and make sure that there's nothing running. Okay, so I think some of the things that you should watch out for are elastic IPs, right? NAT gateway. Okay, this can be expensive. You may have created a VPN gateway sort of thing. These can be expensive, right? So also you might have armies, right? Armies. You may have some snapshots, and of course servers, right? The most expensive is servers, so EC2 or RDS instances, right? Especially if they're not micro. Okay, so especially if not micro instances, because micro is free tier, right? Anything else is not free tier. Okay, all right. Parameter groups and options, they will not cost you. Okay, they're just configuration, right? Don't worry about these things. And some parameter groups and options will have to be there because when you launch an instance, that those are the things that will be used. Okay, so those may be sort of default options and groups which cannot be deleted. Okay, and then they don't cost you anything, right? Things like security groups, parameters, these are just configurations, right? They don't cost you anything. Okay, all right. What is Oracle? What's your bring your what is bring your own license? Yeah. So this is where with commercial products, right? With commercial products, especially things like Oracle, where your existing investments, right? You have already bought licenses, right? Your existing investments need to be protected, right? So you have already paid for it. Now you're moving to the cloud, right? So then will your existing investment go wasted, right? So what you can do is, so the answer is no. You can protect your investment. So you can basically transfer your existing license to the cloud. Okay, so talk to AWS. You know, talk to AWS, and AWS will have an arrangement with Oracle. Okay, so they will sort of handle on that. Oracle, basically Oracle will pay them a bit because it has already collected from you, right? So something like that is what will happen. Or basically they won't pay Oracle anything extra because they're basically reusing existing licenses. Okay, something like this. All right. Okay. More explanation on parameters and attributes. No, so these are, look, what happens is when you have an RDS instance, right? So you have things like parameter groups, right? This is what you're talking about. Okay. So these are, when you remember, RDS is a platform, right? And you don't have access to the operating system, right? But if you had access to the operating system, you could go into, say, etc MySQL or my.cnf, right? You can go and configure your database, right? Database server. So things like, what's the buffer size and all those things you can configure, right? What's the character character set? Do you have UTF-8, right? Buffer, things like cache size, right? Where's your log file stored? All these things. Each, the database server has lots of configuration, right? How much memory to be used for what. So all these things have to be specified somewhere, right? So yeah, so things like this, InnoDB, buffer, pool, right? All these things are sort of configuration items that you can tune normally when you run your own database on your own server, right? But in RDS, there's no server, there's no operating system, you can't SSH anywhere, right? So then the question becomes, how do I configure my database, right? That's what this is. Okay, that's what this is. So you can create your own parameter group and attach to an RDS instance. So this is, the parameter group group is basically DB server config. All right, because with RDS you don't have access, you don't have OS access, right? So you can't configure your DB in the OS, right? So for example, my.cnf, right, is what you configure for MySQL. So my.cnf is not available to you, right? It's not available to you. Instead, you have access to this parameter. You can create your own parameter group basically. Okay, so yeah, so that's what this is. All right. From the quiz, how can two VPCs have the same IP address range? The answer was two VPCs can have the same IP range. Oh yeah, they can because each VPC is isolated, right? Each VPC is an isolated network, right? So it doesn't matter, right? It does not matter if both have the same range. You can try this out. You can easily create two VPCs with the same range. Okay, unless you peer them, right? Unless you peer, then you can't peer them. Okay, so if you want to peer two VPCs, then you must have different IP address ranges, right? But otherwise it's fine. Okay, so for peering, the two VPCs must have different ranges. All right, otherwise it's fine. Otherwise it doesn't matter, because like in my home I have 192.168 IP address, 192.168 say 1.1, right? You have the same in your home network, I'm sure, right? So that's because your network is completely private, my network is completely private. The two networks will never talk, right? So it can have the same IP address range. All right, okay. So I got billed using NAT gateway. What scenario could have triggered? Yes. So NAT gateway is in scenario 2. Yes. So NAT gateway is in scenario 2, right? So I think what happens here is you should delete, right? You should delete VPC scenario 2, right? So just go to the VPC and say delete. All right. But before this, terminate all resources, right? EC2, RDS, etc. Right? When you delete the VPC, it may say unable to delete, right? Unable to delete. Okay, so don't worry, right? Don't worry. Wait a bit and try again, right? So it'll clean it up nicely. It normally, if you do this, right? If you do this, it will remove the NAT gateway also, right? So what happens is, you try to delete the VPC. It takes time to delete it because lots of resources have to be deleted. So it times out basically, and it says unable to delete, right? But don't worry, just wait for it and try again. It'll do it. Okay, so yeah, NAT gateway is from scenario 2. Okay, but still, it's very small, right? It's only 5 cents per hour. So your bill was $1.5, which you can see the breakup. You can see the breakup in the details, right? If your NAT gateway was running for an hour, I don't think it will cost you $1.50. Okay, so that you can go and check in your details, in the bill details, right? It's only 5 cents, right? As per your message here, NAT gateway is only 5 cents per hour. So $1.50 is pretty big, right? Is pretty big. Okay, so it should not have been that high unless you left it running, right? Unless it kept on running for a bit. All right. Okay. Yeah, 12 hours maybe. Okay. Yeah. All right. Okay. Can we have a 1 hour Q&A in the next week, 15th or 16th May? after that, so that we can try out all these competitive issues queries. That'd be possible. Yeah, I think so. But I'm actually traveling. But Monday should be fine. Monday should be fine. So let's finalize around Friday, right? Let's finalize on Friday. You can bring this up again, and let's sort of finalize the time and date as well. All right. But I think Monday is fine. Okay, this one. What's security group rule /0? So that's just sort of unrestricted access, which means all IPs allowed, right? So anybody can connect, right? Which you should not do for SSH, not for SSH or RDP. SSH or RDP, right? So you should not have something like that for that, but okay for HTTP or HTTPS. Okay, whenever you see that /0, that means yeah. So and that 2 colons may be for IPv6. Okay, so unrestricted access, right? And may be referring to IPv6. Okay, because they're trying to introduce IPv6 support. Okay, so normally it's that 0000/0, right? That's IPv4, and then if it's followed by this 2:/0, that's referring to IPv6, which they are trying to add now. Okay, but the end result is it's unrestricted access. All right. Okay. All right. Redshift is NoSQL. No, it's not NoSQL actually. Right? It's not NoSQL. And I don't know why. I don't know where you read this as unstructured. Right? It's definitely structured. I think so. Look, it's not NoSQL. It's actually the history is there was a company called something like this, PowerXL, right? Which AWS acquired, right? And this company, PowerXL, they used an older version. They forked Postgre. Okay, they forked PostgreSQL, and then they built that MPP on top of it, right? MPP on top. So it's basically the history and the foundations are PostgreSQL, which is relational database, right? So I don't think there's any unstructured aspect to it. Okay, it's not NoSQL. I don't think so. But if you can sort of show the sort of get the source for this, right? We can discuss it more. But I mean, as far as I know, it's only structured database. All right. Okay. Yeah. Okay. Now this one, right? I think we won't have time today. Okay, because we have to sort of create the instance and all that. But look, what you have to do is, make sure from EC2, right? Once you log in SSH to EC2, okay, SSH to EC2, and assuming your EC2 instance and RDS is created in public, in the default VPC, right? So create EC2 and RDS in default VPC, right? Use default SGs for both so that it's open, right? You don't have to fight with networking issues. Okay, so then SSH to EC2, and then from the prompt, first you need a MySQL client, right? You need a MySQL client. So you need to basically you have to do sudo apt-get update, okay, and then sudo apt-get install MySQL client. Okay, this client will let you sort of connect. Okay, once you do that, you simply have to do this. MySQL, right? -h the RDS endpoint. Okay, without the port, no need for port. All right, then -u whatever user you set up, right? RDS user -p. Okay, you can use -P if you like for port, which is I think 3389. Right? This is what you need to do, right? This is what you need to do, and that's it. That's it. So let me just make sure that I have the correct command. Yeah. So something like this, right? Something like this. So this is just an example, but This is exactly what you need to do from the EC2 instance. All right, this user will be the one that you create when creating the RDS instance. All right, so so the process is the same, whether you connect from the local machine or from the EC2 instance. Process is the same. Yeah, let's discuss. Because on 22nd, I'll have to check my calendar. There could be another batch, right? There could be another batch which might be starting. So let's again come back to this. Okay, let us come back. I'll have to check my calendar. Come back to this. We will decide by Friday. Okay. Sure. No problem. No problem. Yeah. Yeah. All right. Fine. All right, folks. So yeah. Okay. So I'll see you tomorrow. Have a good night. Bye.